Okay, we're going to take a look at implicit differentiation. What does this mean? Well, you're going to be taking the derivative of things, of functions, where you don't actually know what the function is. M and a D. I still don't know what that means. Doesn't matter. Here's what I want to say. Really, implicit differentiation just utilizes the chain rule a bunch of times. So the chain rule, just to reiterate, is the derivative of the outside with the inside the same times the derivative of the inside. And then there's a little bit of a caveat. But let's take a look at the first example. So here we have it. Assume that y is a function of x, meaning there's an equation. Y is a function, okay? And find dy dx. All right. Something that I'm going to point out. In this problem, there are a couple of different functions. First, I have that x cubed out in front. That's easy to take the derivative of. I'm going to be doing dy dx. That's what it said. Take the derivative, d dx. Take the derivative with respect to x. That's what it's saying. So x is our main variable. Okay. So then I have a cosine in here. Cosine. I have a cubic function. Remember, you can rewrite cosine cubed of y. You could rewrite it like this. Maybe you want to write it like that just to help you think about it. There's the cosine function in there. There's the cubic function in there. There's a 5x. And the weird part is the y. Well, y is not a function of x. That's crazy. That's crazy. So, these are all the types of functions that I have, and I'm trying to take the derivative. And that's the same thing as doing d dx of the entire thing. I guess both sides. So, what do? Well, we can take the derivative fairly simply of x cubed. That's just using a power rule. So, that would be 3x squared. And then this stuff, oh boy. The derivative of the outside with the inside the same. This is chain rule. So I'm going to do plus 3 something squared. The inside is the cosine of y. So there we go. Move that down a bit. So that's the derivative of the outside with the inside the same times the derivative of the inside. Well, the inside is the cosine of y. So all times, well, that's another chain rule because we have a function on the inside. Ooh, anytime that thing on the inside is different, we got to use chain rule. So times negative sine, derivative of the outside, the inside is y, with the inside the same, times the derivative of y. Now, remember, x is our main variable. Anytime you're taking the derivative of something that's not your main variable, well, in this case, you're going to tack on a dy dx. So pretend like the y is your main variable. The derivative, pretend like it's an x. The derivative of x is just 1. So the derivative of y is just going to be 1. But y is not x. So anytime, this is the rule that I'm telling you, anytime you're taking the derivative of a variable that's not your main variable, you're going to tack on a dy dx. And that's just using the chain rule. If y is a function of x, if you don't understand this, that's okay. Maybe eventually you'll get it after much more practice. But the derivative of the outside would just be 1, and the derivative of the inside would be dy dx. We just don't know what y is. Alright, and then equals, we still got to do this part, equals the normal derivative of 5x, which would be 5. I'm going to rewrite that. So I rewrote it, and now I'm going to solve for dy dx. I'm going to get dy dx all by itself. And that should be fairly simple. So I'll subtract 3x squared over to the other side. So that goes away. And then this is all multiplication there. So I'm going to divide by negative 3 cosine squared y times sine of y. And I'll do that to both sides. Negative 3 cosine squared y sine of y. And there you go. There you go. we've just solved for dy dx. Now we have a function, the derivative of this curve, whatever this looks like. It's going to be something, I don't know what it looks like. It looks like it's going to be something weird. But we have a formula for the slope of the tangent line, and it also involves y. It's in terms of y and x. So there we go. That's the derivative. Anytime you're taking the derivative of something that's not your main variable, you take the derivative as if it were the main variable, and then you tack on a dy dx. Alright, I'll write that down. That's not going to make sense until the other examples, I think, but there will be more examples. So anytime you take the derivative of a variable that is not your main variable, so we took the derivative of y, even though we're taking, we were using d dx, taking the derivative with respect to x. X was the main variable. Anytime you take the derivative of a variable that's not your main variable, take the derivative like normal, then tack on a dy dx. That's how you would do implicit differentiation. Okay, time for another example in a different video.